This is a May, June 2023, variant 42 question. Number 4. A small steel sphere is of mass M is oscillating vertically on the end of a spring as shown in figure 4.1. The velocity v of the sphere changes with the displacement x from its equilibrium position according to this equation. V equals to plus or minus 9.7 square root of 11.6 minus x squared, where V is in centimeter per second and x is in centimeter. A part 1, calculate the frequency of the oscillation. To calculate the frequency of the oscillation, you must first find omega. To find omega, you must compare the equation which is given to you to V equals to omega square root of xo squared minus x squared, where omega equals to angular frequency or angular velocity. Xo is the amplitude or the maximum displacement. X is the displacement. So comparing the two equations will give you omega equals to 9.7. Therefore, F equals to 9.7 divided by 2 pi, which will give 1.5 Hertz. Part 2. Show that the amplitude of the oscillation is 3.4 centimeter. Again, by comparing the two equations, you find that xo squared equals to 11.6. So xo equals the square root of 11.6, which will be 3.4 centimeter shown. Then your part 3, you have to calculate the maximum acceleration AO of the sphere. The formula for maximum acceleration is minus omega squared xo, which means you must know omega and xo. Substituting the values into the equation will give you the maximum velocity acceleration equals to 9.7 squared times 3.4 times 10 power minus 2, which will give you 3.2 meter per second squared. Part B. On figure 4.2, sketch the variation with x of the acceleration A of the sphere. Before you can do this question, you must know that the maximum displacement is 3.4 centimeter or the amplitude is 3.4 centimeter, and the maximum acceleration is 3.2 meter per second squared, which is same as AO. This question carries 3 marks. To get the 3 marks, you must say that 3 points. First, you say that you must draw a straight line with the negative gradient passing through the origin. So this is the line that you draw. The origin is this point here. The second mark comes from the line must pass through the red point, which is this point. That the coordinate for the red point is positive 3.4 minus A max, and the blue point, which is this point here, minus 3.4 A max. Then the third point, the third mark comes from the line with ends at x equals to plus or minus 3.4 and A equals to plus or minus A0. The third point is the same as the second point. Then for part C, describe without calculation the interchange between the potential energy and the kinetic energy of the oscillation. This question carries 3 marks. So first you must say that the sum of the potential energy, EP, and the kinetic energy, EK, is constant. This is the total energy of the vibrating system. Number 2, at maximum displacement, the EK is 0. Meaning at the maximum displacement, the object is stationary since your EK is 0. Or you can say that at maximum displacement, EP is at the maximum. Then the third point is at 0 displacement, your kinetic energy is maximum, meaning the object is moving the fastest. Or you can say at 0 displacement, EP is minimum or EP equals 0 joule. 0 displacement means equilibrium position. This is a summary of the facts that you must know to solve this question. Number 1, you must be able to use the equation V equals to plus or minus omega square root of xo squared minus x squared. Number 2, you must be able to calculate the frequency and the maximum acceleration when the angular frequency and when angular velocity omega is known. Number 3, describe the interchange between kinetic and potential energy during simple harmonic motion. Number 4, know that the sum of the potential energy and kinetic energy remain constant when the mass undergoes simple harmonic motion. Number 5, understand that the potential energy is maximum and the kinetic energy is 0 when the displacement of the mass is maximum. Similarly, the potential energy is 0 or minimum, and the kinetic energy is maximum when the displacement is 0. 0 means displacement 0 means at equilibrium position. And then finally, you must be able to draw the acceleration displacement graph for a mass undergoing simple harmonic motion.